Step past the yellow tape, my friends, and welcome to the evidence room. I am your lead detective for today's explainer, and we are opening up a highly classified, incredibly high-stakes forensic investigation. We're digging deep into case file 9709. Specifically, we're zooming right in on the Cambridge A-level mathematics syllabus, topic 2.6, numerical solution of equations. And our entire focus today? Locating roots by sign change. Now listen, to the untrained eye, a past exam paper just looks like a random scattering of numbers, letters, and vague command words. But to us, to an elite exam detective, it is an intricate crime scene. It is literally filled with hidden forensic clues left behind by the examiner. Every single mark on that paper is a piece of evidence just waiting to be collected. But you have to know exactly where to look, and more importantly, how to process it without completely contaminating the scene. In this investigation, we aren't just going to look at the math. No, we're going to get right into the psychology of the examiners who set these traps. We're going to deconstruct the official principal examiner reports, track the exact cognitive domains they are testing, and build a bulletproof 100% resolution strategy to help you completely clear your upcoming exams. So, secure your notes, keep your eyes on the evidence board, and let's process this scene.
Okay, let's dive into this incredible quote directly from a senior examiner. They said, "The difference between a B and an A star in mathematics often comes down to how well you understand locating roots by sign change." Now, you might be wondering, why on earth is this specific topic the ultimate dividing line? Well, it's because this isn't just a standard calculation where you punch some numbers into a calculator, hit equals, and spit out an answer. Absolutely not. It is a strict forensic procedure. You see, when you're just looking for a B grade, you're usually just gathering raw facts. But when you are hunting for that A star, you have to build a coherent case, motive. You are proving beyond a shadow of a doubt that a mathematical entity, a root, exists in a specific location, hiding right there between two values. You are building an undeniable chain of evidence. If your chain is weak, or if you skip a step, the examiner throws the entire case out of court and your marks go right out the window with it. The clock is constantly ticking down in that exam hall, and mastering this specific assessment objective is literally the thing that elevates you from a rookie investigator to an absolute elite exam detective.
So here is our investigation blueprint for today's session. First up, the case file briefing. Second, we'll map out the procedural framework. Third, we are elevating to critical analysis. And finally, we'll lock in on the top 3 examiner alerts. Let's get to work.
Let's crack open the first folder on the desk. Section 1, the case file briefing and core concepts.
Right, before you can solve any case, you absolutely have to understand the laws of the universe you're operating in. The examiner is not just testing your ability to plug a number into a given function. They are testing a deeply layered conceptual framework. If you look at this assessment framework, it maps directly onto 3 distinct cognitive domains: knowledge and understanding, application, and analysis. Let's actually think about this through the lens of 2 hypothetical investigators we'll call Agent Alex and Agent Sam. Now, Agent Alex is fantastic at that first column, knowledge and understanding. Alex can literally memorize every single formula in the textbook, gathering vast mountains of physical evidence and raw facts. But Alex lacks a coherent case motive. The exam answers end up just being huge data dumps with absolutely no high-level analysis. Then, on the flip side, we have Agent Sam. Sam is fast. Sam jumps straight to column 2, application. Sam plugs in the numbers, spots a sign change, and jumps to an immediate rushed conclusion. Sam completely skips the vital forensic confirmation steps and misses the examiner's exact command word constraints. Listen to me, both Alex and Sam are going to lose heavy marks here. The Cambridge assessment framework heavily prioritizes analytical depth over superficial breadth. Logical, highly structured reasoning across all 3 of these columns is the ultimate benchmark. You must know the principle, apply it flawlessly, and then, crucially, analyze what that result actually means in the context of the crime scene.
So the crucial point is that this theoretical architecture rests on precise definitions, tight causal relationships, and most importantly, seamless integration with other syllabus areas. The official principal examiner reports explicitly state that candidates who reference cross-topic connections achieve significantly higher marks. Think about it. Locating a root by sign change does not just exist in a vacuum. It is deeply connected to calculus, to curve sketching, and to complex algebraic functions. When you are proving a sign change from, say, positive to negative, you aren't just doing basic arithmetic. You are demonstrating to the examiner that a continuous curve physically crosses the x-axis. Actually, scratch that. Let's look at the trap here. If the function isn't continuous, say, for instance, there's an asymptote right in the middle of that interval, a sign change doesn't mean a root exists at all. The curve could just break, shoot down to negative infinity, and reappear at positive infinity without ever actually touching the x-axis. Recognizing that kind of causal relationship is exactly how you prove to the examiner that you have total, undeniable mastery over the evidence. Moving on to phase 2 of our investigation, the procedural framework and methodology. I want you to think of this as the rigorous, non-negotiable protocol you must follow the very second you step up to the exam crime scene. If you contaminate the scene by failing to clearly show you're working, the marks are gone, period. This brings us to a heavily guarded secret of top-tier candidates, the method mark strategy. This is an assessment protocol where marks are explicitly awarded for demonstrating the correct procedural process, regardless of whether your final numeric answer is perfectly accurate. The examiner is literally forensically tracking your exact processing steps. They are looking closely at your trail footprints. Did you substitute the first boundary value correctly? Did you substitute the second boundary value? Did you explicitly show the calculation result on the paper before declaring the sign change? If you just write down the final answer, you are essentially asking the examiner to just take your word for it. And in this investigation, we don't operate on trust. We operate on documented proof. The method mark strategy dictates that your working out is the actual evidence. And this brilliantly illustrates the standardized sequence required to secure those critical process marks. It is a strict 5-step procedural framework. Step 1, identify key elements. What exactly is the function? What is the specific interval? Step 2, apply relevant principles. This means clearly setting up your f of x correctly on the page. Step 3, execute analysis with clear working. Now pay attention because this is where you physically write out the substitution of your boundary values into the equation. There is absolutely no skipping straight to the calculator output here. Step 4, verify results. Check the signs. Are they actually different? Are we going from positive to negative or vice versa? And finally, step 5, present format. State the conclusion clearly based entirely on the evidence you just presented. If our impulsive agent Sam rushes in and skips step 3 just to get to step 5, the chain of custody is completely broken. The examiner will withhold the method marks, no questions asked. You must execute every single step in this exact sequence to build an airtight case. To maintain that airtight case, practical application requires strict adherence to conventions. We're talking proper headings, correct mathematical terminology, appropriate formats, highly clear annotation, and accurately extracting data from text and tables. When you officially declare that a root exists, you must use the correct terminology. Please, whatever you do, don't just write, "It changed, so there is a root." You have to state it clearly. F of A is greater than 0 and F of B is less than 0. Therefore, there is a sign change indicating a root lies in the interval between A and B. That level of clear annotation is exactly what the examiner uses to verify your logic. It is the professional paperwork of your investigation, and it has to be flawless.
Let's open up Section 3, elevating to critical analysis and high-level evaluation.
All right, now we enter the cross-examination phase. We are moving our explainer into the exact territory that separates the basically good investigators from the absolute elite. It is time to elevate the evidence from basic standard procedure up to high-level evaluation. Let's move to this comparison and see how this builds a massive, undeniable advantage for you. We really need to distinguish between a descriptive level response and an evaluative level response. Remember Agent Alex? Alex often writes descriptive, superficial statements of fact. Alex will write something like, the value at 1.5 is positive and the value at 1.6 is negative. Now, that is a true statement for sure, but it is purely descriptive. It is basically just a fingerprint match error. It states what happened without explaining why it matters or testing its mathematical validity. The examiner demands an evaluative level response. This means actively questioning assumptions, evaluating alternatives, and providing fully justified recommendations. An evaluative argument acknowledges the mathematical constraints. It says, assuming the function is continuous over the interval 1.5 to 1.6, the change in sign from positive to negative mathematically necessitates the presence of at least one real root. Do you see the difference there? The evaluative response cross-examines the data and confirms the exact conditions under which the evidence is actually valid. It's a game changer.
The traits of top-scoring candidates closely mirror those of a seasoned lead detective. They don't ever just accept the numbers at face value. They systematically question assumptions and justify their decisions with hard, verified evidence. Look at this matrix. First, they identify limitations. Is the interval too large? Could there be multiple roots hidden in there? Or, here's a classic trap, what if there's an even number of roots where the sign dips down into the negative and comes right back up to the positive, totally hiding the evidence entirely? Next, they question the assumptions made, like the continuity of the curve we just discussed with the asymptote example. They constantly consider alternative interpretations and determine exactly how those factors affect the final conclusions. If you just blindly state a root exists without verifying these specific parameters, a sharp examiner is going to penalize you hard for not fully evaluating the quality of your evidence.
Which brings us to Section 4, the top 3 examiner alerts. This is the suspect bulletin, folks.
We are entering the final phase of our investigation, and I have pulled the direct case-losing errors straight from the official Cambridge Principal Examiner reports. These are the brutal traps that catch out thousands of candidates every single year. Let's look at the suspect bulletin. Pay extreme attention to this alert. The principal examiners have flagged 3 primary offenses. Number 1, confusing cause and effect. Candidates often state that because there's a root, there must be a sign change, completely reversing the logical flow. You must use the sign change as the forensic evidence to prove the root, not the other way around. Number 2, forgetting to check format and presentation. This goes right back to our method mark strategy. Dropping negative signs, failing to explicitly write out the substituted equation, or rounding prematurely during the calculation phase, all of that destroys the integrity of your evidence. And number 3, providing generic answers that are not specific to the context. This is where a stressed candidate just memorizes a textbook definition and pastes it into their answer without actually looking at the specific function or interval provided in the exam question.
Now, what's really interesting and absolutely crucial about this slide is that this third point is considered the absolute fatal error. Providing generic answers is literally like bringing evidence from a completely different crime scene into the courtroom. The judge, in this case the examiner, will throw it out immediately. You cannot just write a sign change means a root. You must explicitly link every single point to the given scenario. You must reference the specific numeric values, the specific function name, and the specific bounds of the interval given in that exact past paper question. If you fail to contextually link the sign change evaluation directly back to the specific exam scenario, you forfeit the analysis marks entirely. Case file freeze. Listen to me. Before we lock in our final suspect profile and finish up this case, I need to make sure your intelligence feed is secured. Take a second right now. Picture a police folder opening up right now on your screen, revealing a ringing notification bell. Hit that subscribe button for Ace the Exams, at Ace the Exams, and turn on all notifications. You do not want to miss our weekly forensic exam updates, whether you are cracking cases at IGCSE O levels or ASNA levels. All right, let's close this out.
As we officially close this case file, I want to hand the investigation files over to you for a live forensic check. I want you to look at your own recent practice papers, perform a final, ruthless evidence audit on your own work. Ask yourself this absolutely critical question. Does your next response simply describe the equation like Agent Alex, or does it critically evaluate the evidence like an elite exam detective? Remember, the difference between describing and evaluating is literally the difference between a B and an A star. Use the 3-step question scan to decode the command words, allocate your clock budget wisely so you don't rush like Agent Sam, and always run a final evidence audit to ensure you haven't left any flimsy, generic answers on the page. Drop a comment below right now sharing exactly which Cambridge subject and level you are preparing to conquer next. Thank you for joining me in the evidence room for this explainer. Keep your case files organized, keep questioning the evidence, and apply this forensic mindset to every single paper you face. Good luck on your next masterclass. Case closed.